Relations. A relation is two numbers that are somehow related to each other. We may not know why they're related to each other, but for some reason they are connected with each other. Generally, we think about relations when we're talking about math as an input, as an output. You've heard of those terms since elementary school. We input a number and we get an output. We've got more algebraic terms. We also talk about the domain and the range. We also talk about the x value and the y value. So one way to represent a relationship is with ordered pairs. So here's a set of ordered pairs to represent this relation. We have an x value and a y value separated by a comma in parentheses. You'll notice that we've got a whole set of ordered pairs here, and we enclose them in our brackets. So one way to represent a relation, ordered pairs. Another way to represent a relation is through a table. You can do a table vertically or horizontally, whichever looks more appropriate with the data you're working with. These are the same relations as in the ordered pairs, just represented differently. Notice I have my x, or my domain, my input on the left-hand side, my y, my range, my output on the right-hand side. That's generally how we do it. If I write my table horizontally, input is on the top, output is on the bottom. Notice 4, negative 3, they go together here. 4, negative 3 is a ordered pair from my first list. So it represents the same data, just in two different ways. A third way to show that data is through a mapping. You may not have seen a mapping before, so let me kind of break it down. So mapping has two long, thin ovals, so they're tall and thin. My x value is on the left, my y value is on the right, so very similar to how we look in a table. I like to put the numbers in my mapping from least to greatest going down in both of them. Notice that's not the way we have them in the ordered pairs or in the table. But things get a little more kind of chaotic in the middle of a mapping, so that helps me to put some organization on it. You'll notice that these are the same values. So I have negative 4, 1. That's one of my ordered pairs. I have 0, negative 3. That's another one of my ordered pairs. I have 3, 2. That's an ordered pair. And 4, negative 3. That's another of my ordered pairs. So I have 4 ordered pairs here. How I'm representing the connections between the two is with an arrow. You'll notice that 2 of these ordered pairs have the same output. 4, negative 3 and 0, negative 3 have the same output. So I'm using the same output value twice. I only wrote it one time though. I didn't need to repeat it like I do here in a table or in an ordered pair. I only had to write it once. I can also represent a relation as a graph, which you're used to seeing. Please make sure when we're graphing that we use graph paper. Please do not draw lines on a piece of white lined paper or just make a rough sketch. Please use graph paper. I'll give you plenty. Take it home with you. Make sure you've got extra. So on a graph, when we're graphing a set of ordered pairs, we use our x-axis and our y-axis, and we use the values to create those ordered pairs. So these all represent the same relation, just in 4 different ways. So when we're talking about relations, we can talk about relations in a specific setting. So talking about a word problem, talking about a situation where I've dressed up the situation and I actually know what's happening and why those two, that input and that output, are related to each other. So let's take a look at a little bit more of how this works. So just to clarify some different ways of talking about the two variables in a relation. We've talked about the domain, which is also your x value or your input. It's also what we call your independent variable. And your independent variable is unaffected by the dependent variable. So if you're looking at a word problem, trying to figure out which one's the independent and which one's the dependent, see if you can figure out which one of them is unaffected by the other. That is your independent variable. Doesn't make any difference to that variable what the other is doing. It's independent of the other. The range value, or the y, also the output, that's your dependent. It really does depend on what the independent variable is doing. It really matters to it what the other one is doing. It changes it and it affects it. So one question you might be asked is, here's a word problem. What's the independent variable? What's the dependent variable, or that output? So the air pressure inside a tire increases with the temperature. So if we try to figure out which one of these is unaffected by the other, well, the air pressure in the tire totally depends on the temperature, so it is affected. The temperature, however, is unaffected by the air pressure in the tire. So the unaffected value, that's our independent variable. So our independent is our temperature, which means our dependent is our air pressure. So think about which one is unaffected. That's your independent variable. We might also be given a graph. This is kind of just a loose graph. We're not talking about specific points on this graph. And asked to describe be asked to describe what is happening. So I have time as my input, time as my independent variable, and I have distance as my output or my dependent variable. So we're just going to describe what's happening here. I don't know if this is someone walking or someone driving a car. We don't know how they're moving, but there is some distance that is happening as time is passing. Notice the time is my independent. Time is not affected by distance, but in this case the distance, how far this person has traveled, is affected by what time it is. So if I look at how they're traveling, I'll notice that their distance is getting greater, and then we've got this horizontal line here, so we know they stop because there's an amount of time where the distance doesn't change. And then they go what appears to be more slowly than that first movement here, and then they stop again, and then they pick up their speed and they start traveling. So this person is traveling. They're definitely moving along. There's two parts where they are stopped, and there's one part in the middle here where they tend to go more slowly. So we really want to just describe what's happening in each part of the line on that graph if we can. If we can't describe what's happening in each part, we can at least give a general idea of what's happening. They're traveling. They stop at a few points in the middle here. They're not going at a constant speed.